In this video, we are going to focus on factoring polynomials that are binomials. Now, binomials are a special name for polynomials. So one of the keys in factoring difference of two squared is recognizing the pattern. Another key is to always take out greatest common factor. It will make the number smaller and much easier to work with. Okay, let's take a look at this one right here, x squared minus 49. And we want to factor this. So let's go ahead and check to see if we polynomial with two terms. And we have to check to see if x squared is a perfect square. So let's take square root of x squared. Well, square root of x squared is x. And then let's take square root of 49. Square root of 49 is 7. So yes, x squared is a perfect square. 49 is a perfect square. Is it a difference? Yes, it is. It's minus. So therefore, we have a difference of two squares. So how do we factor a difference of two squares? Well, we have a procedure that we can use to factor it. So here it is. Here's your procedure. Okay, step 1, identify the polynomial as a difference of two squares. We did that. We identify the polynomial. It's a difference of two squares. Step 2 is to take the square root of each binomial. And we did that. We took the square root of x squared. We took the square root of 49. They're both perfect square. And then after you do that, step 3 is to rewrite the polynomial as a product. So you have to rewrite it as a product and difference of those perfect square root. So here we're going to have the perfect square of x squared is x, so you need an x and an x. Okay, sum and difference, so you need a plus and a minus. And then square root of 49 is 7. Okay. So factors of x squared minus 49 is x plus 7 times x minus 7. Okay, so, and then you can check it to see if these two are the correct factors of x squared minus 49. And to do that, you just have to multiply these two binomial. Okay, and if it comes out to x squared minus 49, then you know it's right. So we have to identify if this is a difference of two squared. Well, let's see. We got a binomial. We have 4x squared is a perfect square because 2x times 2x is 4x squared. 25 is a perfect square because 5 times 5 is 25. And then you also have a difference. So yeah, you have a difference of two squared. So let's go ahead and factor this with the procedure. So the procedure is right here. Step 1 is to identify the polynomial as difference of two squared. We did that. We were able to identify. Step 2 is to take the square root of each binomial and take square root of 4x squared. So what is square root of 4x squared? Well, square root of 4x squared is 2x, right? Because 2x times 2x is 4x squared. And what about square root of 25? Well, square root of 25 is 5 because 5 times 5 is 25. So that's step 2. Step 3 is to rewrite the polynomial as a product using sum and difference of these perfect square root. Okay, so we're going to write it out. A square root of 4x squared is 2x, so we need a 2x and a 2x. And then we need a plus and a minus. And then square root of 25 is 5. Okay, so 4x squared minus 25, we factor that out into 2x plus 5 times 2x minus 5. All right, let's take a look at another one right here. You got 9x squared minus 36, and we're going to factor this. Okay, here's the procedure. All right, so step 1 is to identify as difference of squares. So we have 9x squared. Is that a perfect square? Yes, it is, because 3x times 3x is 9x squared. And then 36, is that a perfect square? Yes, it is, because 6 times 6 give you 36. Now, if you look at this expressions right here, remember what I said at the beginning, that one of the keys to factoring difference of two squares is to always take out greatest common factor. So if you look at these two terms, you have a greatest common factor other than 1. So you're going to have to pull that out to make things a lot easier. It just makes it a lot easier. Now, you don't have to do it that way. It's not wrong to do it, but it just makes it a lot easier. So tell me, what's the greatest common factor here? Now, the greatest common factor here is 9. So we're going to pull out 9. So when you pull out 9, 9 goes into 9x squared, x squared times. And then 9 goes into 36 4 times. Now, when you pull out 9, what's left is still, if you have a difference of two squares at the beginning, after you pull out your greatest common factor, you're still going to have difference of two square left inside the parenthesis. So it just makes it a lot easier to factor x squared minus 49, right? Because the numbers is a lot smaller. All right, so we're going to go ahead and factor x squared minus 4. Okay, so first thing we got to do is identify. We did that. We identified the 9x squared minus 36. So that's the x squared minus 4. So that's step 1. What do we do for step 2? Well, step 2 is we have to take the square root of x squared, and then we have to take the square root of 4. So let's see, square root of x squared. Well, tell me, what's the square root of x squared? Well, that's just going to be x. And then we have to take the square root of 4. So what is the square root of 4? That's 2, because 2 times 2 is 4. Okay, so that's step number 2. Moving on to step 3 is to rewrite the polynomial as a product. So here we have square root of x squared, right? That's x. Okay, so we need an x and an x. We need a sum, and we need a difference. And then square root of 4 is 2. Okay, and then don't forget to bring down the 9, because that's still one of the factor. So now when you factor 9x squared minus 36, you get these 3 factors. Okay, so if we multiply all these 3 factors, we get the 9x squared minus 36. Okay, let's look at another one here, 16x squared minus 81y squared. And we have to factor this. Let's look at the procedure. Okay, so first thing we have to do is identify the polynomial as difference of square. Well, let's check. 16x squared, is that a perfect square? Well, yes it is, because 4x times 4x gives you 16x squared, so that's a perfect square. So that, okay. What about 81y squared? Is that a perfect square? Well, yes it is, because 9y times 9y is 81y squared. Okay, so that's also a perfect square. And we have a difference. So therefore, we have a difference of two squares. So step 1 is to check it. Now step 2 is to take the square root of each of these terms. So we got to take square root of 16x squared. And then we have to take the square root of 81y squared. So let's go ahead and do that. So here's square root of 16x squared. So what is square root of 16x squared? Well, that's 4x, because 4x times 4x is 16x squared. What about square root of 81y squared? Well, square root of 81y squared is 9y. Okay? So that is step number 2. And then step 3 is to rewrite the polynomial as a product. Okay, so we're going to rewrite it using the sum, okay, and the difference of these 4x and then 9y. So what do we have? We have 4x times 4x, okay, and then we have 9y. All right, so when we factor 16x squared, take away 81y squared, we get 4x plus 9y times 4x minus 9y. Now, if we were to multiply these two binomial, then we get back the original expression. Okay, let's take a look at another one here. 16x cubed, take away 4x. And we are going to factor this. And here's the procedure. Okay, we're going to go through this step by step. All right, so step 1 is to identify the polynomial as difference of squares. Well, 16x cubed as it is not a perfect square because x cubed is not a perfect square, even though 16 is a perfect square. So, but if you look at these two terms, okay, you guys remember what I said, that one of the keys to factoring difference of two squares is to always take out greatest common factor. Well, according to this, there is a greatest common factor other than 1. So we're going to have to pull that out and see what happened. So here we have to pull out the greatest common factor, and that is 4x. So let's pull out 4x. Okay, so 4x goes into 16x cubed, 4x squared. And then 4x goes into 4x is 1. Now let's check to see if this is a difference of two squares. Well, let's see, 4x squared, is that a perfect square? Well, yes it is. 4x squared is a perfect square because 2x times 2x is 4x squared. Now, is 1 a perfect square? Well, yes it is. 1 times 1 is 1. So that's a perfect square and it's a difference. So this expression right here is a difference of two squares. So we have it. So step 1 is done. Now let's move on to step 2. What do we do for step 2? We take the square root of 4x squared and we take the square root of 1. So let's go ahead and do that. What is square root of 4x squared? Well, square root of 4x squared is 2x. What is square root of 1? Square root of 1 is 1. Okay, so that's step 2. And then step 3 is to rewrite the polynomial. So we're going to rewrite this. So we are going to rewrite the 4x squared minus 1 as the sum and the difference of those perfect square root. So here we need a sum and we need a difference. So square root of 4x squared is 2x. So 2x and then 2x here. And then positive 1 and then minus 1. And then we bring down the 4x is the greatest common factor. So if we factor x cubed minus 4x, we get 4x times 2x plus 1 times 2x minus 1. And then if we were to multiply this, comes back to 16x cubed, take away 4x. Okay, let's take a look at one more. This is the last one. We're going to factor this binomial, and here's the procedure. So first thing we have to do is identify if this polynomial is a difference of two squares. So let's go ahead and check. X to the 8th power, if we take square root of x to the 8th power, yeah, that's a perfect square because x to the 4th times x to the 4th give you x to the 8th. Now, is 1 a perfect square? Yes, 1's a perfect square because 1 times 1 is 1. So this is a perfect square. This is a perfect square. And it's also a difference. So step 1 is check. Okay, now we move on to step 2. Step 2, we're going to have to take the square root of, so let's take square root of x to the 8. Well, square root of x to the 8 is x to the 4. Okay, because x to the 4th times x to the 4th gives you x to the 8. And then square root of 1 is 1. Okay, so that's step 2. Okay, what do we do for step 3? Step 3 is to rewrite the polynomial as a product using sums and difference. So we have to rewrite it, okay, as a product, multiply. So we need a sum and we need a difference. So here is going to be x to the 4th times x to the 4th. And then here we need a positive 1 and a negative 1. If you look at these two factors, that x to the 4th is also a difference of 2 squares. So because this is a difference of 2 squares, then you have to continue to factor this because you're not done. All right, so we're going to factor this the same way we did. Okay, so here we're going to have, okay, so what's square root of x to the 4? Well, square root of x to the 4 is x squared. So we need an x squared and an x squared. And then we need a sum and a difference. What's the square root of 1? Square root of 1 is 1. And then looking at these two factors, okay, well, x squared plus 1 is not a difference of 2 squares. It's a sum, okay? We cannot do anything with that. Now, but if you look at this, x squared minus 1, that is also a difference of 2 squares because square root of x squared is a perfect square and square root of 1 is also a perfect square. So how do we factor x squared minus 1? Well, we factor into square root of x squared is x, and we need an x and an x. Okay, we need a sum and we need a difference. And square root of 1 is 1, so 1 and 1. All right, so to sum this all up, we have, okay, if we were to factor x to the 8th power minus 1, so x to the 8th power minus 1, and we have to list all the factors. Well, it's going to be x to the 4 plus 1, and then you have x squared plus 1. Okay, so here's your x to the 4 plus 1. Here's your x squared plus 1. Okay, and then you have the last two factors, which are the x plus 1 times x minus 1. So these are all the factors of x to the 8th power minus 1.